Now, before, in order to check whether if two non-zero vectors are parallel, we needed to find a constant c such that u, the vector u, is equal to a constant times the vector of v. Well, the cross product also gives us an easier way to do that. So we have this theorem. Two non-zero vectors, vector u and vector v, are parallel if and only if the vector u cross the vector v is equal to the zero vector. Well, why is that true? Let's prove it. If we have that the vector u is parallel with the vector v, then we know that u is equal to a constant, the vector v. In other words, we have u is equal to c v1, c v2, c v3. Now, if we do u cross v, we have our determinant of I with I hat, j hat, and k hat of cv1, cv2, cv3, v1, v2, v3, and then we have I hat, cv2, cv3, v2, v3, plus, and now we could do the same thing, but let's just look at this one right now. What happens when we calculate this determinant? We get I hat times c v2 v3 minus c v2 v3. Well, this is just going to be equal to 0. So we get 0 times I hat plus the j term plus the k term. Now, if you do the same thing for j and k, you will see that all of these are just going to be 0 I hat plus 0 j hat plus 0 k hat, which in other words is the zero vector. And I would try it as an exercise to make sure you know that you are calculating these j's and k's in the same way. I would try to finish this proof, and you should get that each determinant, each coefficient before I, j's, and k's are equal to 0 themselves. Another theorem we have is that if theta is the angle between u and v, then the magnitude of u cross v is going to be equal to the magnitude of u times the magnitude of v times sine of theta. And theta in this case will always be between 0 and pi. This theorem actually has a very nice geometric application for the area of a parallelogram. Let's have this vector u, and we have this vector v, given by these two parts. Well, knowing our trigonometry, we go down like this, and this is just going to be the magnitude of u sine of theta, if theta is this angle here, correct? Well, what is the area of a parallelogram? Area is just base times height. So we have the magnitude of v times the magnitude of u sine of theta, which we just said was equal to the magnitude of u cross v.